In this video, we are going to find the last digit of the integral part of the fraction 10 to the power 20,000 divided by 10 to the power 100 plus 3. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. My first step would be to try to reduce the size of the numerator, observing that it's a really large number. In fact, it is the 200th power of the power of 10 at the bottom, 10 to the power 100. So I'm going to make use of this identity, which is that for polynomial x to the power 200 minus a constant, say a to the power 200, is divisible by x minus a. In fact, this can be quickly proven by the factor theorem. You simply put x equals a into the polynomial of degree 200 and you will get 0. So x minus a is a factor. Now from this in particular, I can say that 10 to the power 100 all to the power 200 minus 3 to the power 200 is also divisible by 10 to the power 100. Sorry, it's not x minus a, but it's 3 plus a, but it still works. So for plus 3, it's an integer because the denominator is divisible and divides the numerator. So from this, we can say that to find the integral part of the given fraction, it's sufficient to find the integral part of the fraction 3 to the power 200 over the same denominator. The reason is that the difference of these two functions at the left is an integer. Now, for the blue fraction, I can rewrite that as 9 to the power 100 because 3 squared is 9. And I do this so that the exponent both at the top and the bottom are the same. They are both to the power 100. And we can quickly compare both numbers and notice that the number at the top must be smaller than the number at the bottom because of the base. So that means this is less than 1. Now for a fraction that is positive and is less than 1, the integral part is 0. From this, we can immediately conclude that the so-called integral part of our original fraction is just the one we have derived with the help of the polynomial, the one labeled in green. So now it remains to find the last digit of this fraction, in fact an integer. Let me first rewrite that properly. 10 to the power 20,000 minus 3 to the power 200 over 10 to the power 100 plus 3. To find the last digit, I'm going to do the following on this fraction. For the numerator, I'm going to take out 10 to the power 20,000. So I only have 1 minus 3 over 10 to the power 100 all to the power 200 inside the bracket. While for the denominator, I'm going to take out 10 to the power 100. So what remains is 1 plus 3 over 10 to the power 100. I do this because I want both the top and the bottom to be in terms of similar terms. And for the powers of 10 that I've taken out from both entries can be simplified, which gives 10 to the power 19,900 times a fraction in terms of 3 over 10 to the power 100. Now for the fraction, given that it's in terms of 3 to the power 10 to the 100, let's consider the fraction in this way. I let x be that fraction, so then the fraction becomes 1 minus x to the power 200 over 1 plus x. Long division, you should notice the pattern, and is actually equal to 1 minus x plus x squared minus x cubed. So the alternate plus and minuses, plus x to the power 4 minus x to the power 5 all the way up to the last term, which is minus x to the power 199. So from this, we can rewrite the fraction as the power to 10 to the power 19,900 times 1 minus 3 over 10 to the power 100 plus 3 over 10 to the power 100 all squared, and so on. And the last term is 3 over 10 to the power 100 all to the power 199. And in fact, with the help of this power of 10, actually all but the last term will be a multiple of 10, because for the denominator, the exponents are 100, 100 times 2, which is 200, 300, and so on. And the second last term is 10 to the power 19,800, and the last term has denominator to be 10 to the power 19,900. Only the last term has enough factors of 10 to cancel out everything in the green term. So that means if I'm to consider the last digit, I only have to look at the last term, which is over here. So under mod 10, I'm just going to look at the last term, which is minus 3 to the power 199 mod 10, because all other terms will be congruent to 0 mod 10. As for 3 to the power 199 mod 10, notice that there's actually a periodic sequence with period 4, which goes like this. The first one is 3, second one is 3 squared, 9, the third one is 3 cubed mod 10, which is 27 mod 10, so 7, and then the fourth one is 1. So then it starts to repeat, 3, 9, 7, 1, and so on. And since 199 has remained 3 when divided by 4, so this power is congruent to minus 3 cubed mod 10. So minus 27, which means the last digit is 3. So now we have a final answer, which is 3. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.